as we go. Okay, so as you guys know, the class, so to speak, is over as far as new stuff goes. We completed our last exam, and I've graded those, and I have sent those back to you, and I have made comments and whatever. And I did have to put a couple of an announcement in Blackboard about the copying and the cheating, which I hated to have to do, but if you guys could have seen me grading these exams, okay? So a couple of things. First of all, the replacement exams are this week. They're going to be on Thursday. And I had mentioned to you guys that in the next day or so, I would be emailing you over Remind individually and kind of saying, hey, if I were you, I would look into doing this. Those of you who have an A right now, you do not need to take a replacement exam. I have already messaged you, okay? Those of you who I have not messaged, so if you have any other letter than an A, you're going to want to look at your current grade in Blackboard, okay? And it's going to be a percentage, whatever. And I sent out with my announcements the final exam grading scale so that you knew exactly where you fell. So real quick, I'm going to bring that up so that you can see that because I need to make sure that there are no questions on that. So can you guys, yeah, here's the PowerPoint that I showed you on the very first day. And this particular slide is what's important. And so on this slide, it talks to us about the final exam grading scale, okay? And this is how it's going to work. If you, as an individual, have a 90% or higher right now on your pre-final grade, then you do not need to take a replacement exam. And in the second column, you need to score an 85 or higher to keep your A. If you scored less than an 85 on the final exam, the A that you have will drop to a B, and the B will be your final grade. Now, if you have a B right now, so an 80% to an 89%, and you go into the final, if you happen to score a 90 or higher, the B that you have will pop up to this A. If you score a 75, between a 75 and an 89, then you're going to keep your B. If you score less than a 75, the B that you have will drop to the C. If you as an individual are going into the final exam right now with a C, which is a 70 to a 79, if you happen to score an 80 or higher, your C will bump up to a B. If you score between a 65 and a 79, the C that you have is the C that you will keep. But if you score below a 65, then the C drops to a D. Now, for those of you who might be coming into the final exam with a D and you're thinking, oh, should I drop the class? No. All right, you can still get a C in the class. If you're coming in with a D, if you score a 70 or higher, bam, you pass the class with a C, no problem. If you're coming in with a D and you score between a 55 and a 69, then you keep the D. And if you score less than a 55, then your D drops to an F. Now, if you are coming with an F, which is less than a 60%, you might want to consider dropping, but we need to have a conversation because unfortunately, the best that you can do for yourself is to pull your F up to a D, which for the most part is not going to be good enough for your major. Okay, I know a lot of majors are requiring a C in this class. So I'm going to pause for a minute and I'm going to ask you guys, does anybody have any questions that you want to pop in and ask me right now while you can see this grade scale? Okay, hold on. Let me see. Someone's asking me something. Oh no. So yesterday I had a few people message me back and say, can I take a replacement exam? Sure, you can absolutely take any one that you want. However, again, if you are already an A student, that's not going to make a difference. All right. If you have an 80% and you're trying to bump yourself up to an A, there's no way that retaking one exam is going to bump you up 10 percentage points. So my advice is for each of you to look at your current grade in Blackboard later today. If you are 2 to 3 points away from your next grade level or from the next grade letter, consider taking a replacement exam. But if you have an 80 or 70 or something that's really, really low, you're not going to be able to bump yourself up 10 percentage points. So think about it. After we go over class today, I'm going to go through and message people who I think should consider taking a replacement exam, and then I'll let you make your decision. So any other questions on this screen before I go back to what else I need to talk to you about? Okay, so I know we can take a replacement. Okay, so as far as the replacement exams go, you as an individual can only take one replacement exam, and you will have to tell me, hey, I'm taking, exam 3 or whatever. Your lowest exam is not going to be dropped, so to speak. It's the exam that you choose. So Adam, for example, if you were to choose to retake exam 1 and you scored better, the exam 1 score that you initially had, which might have been like a 30%, will be replaced with your better score, which could be an 80%. So technically, I'm not dropping an exam, I'm just replacing it, hence the name. So if you as an individual missed an exam throughout the semester and it's currently put down as a 0, that's going to be your replacement exam, okay? Because it's not going to make sense to take any other one. So if you happen to take one and you do worse than you did initially, it will not hurt you. I will not penalize you. I just will not take that new test score. I'll just say, you know what, you did worse. Good try, but it didn't change anything. Any other questions right now? Okay, so then I also want to show you one other thing in Blackboard. If I can get there. Blackboard. Okay, so when you sign on to Blackboard and you click on your course content over here on the left-hand side, obviously you guys found the final exam stuff folder. Notice the second thing down is the assessment. I think about 6 people have done that. I'm asking that you do that. It can help your grade a teensy bit, but mainly it helps me with my data collection. Okay, so it takes you probably 10 minutes. If you decide to take a replacement exam, the third thing down you're going to see is click here to submit replacement exam work. Whichever replacement exam you decide to take, we're all clicking on the same button right here, and you'll upload the work just like you would if it was a normal exam. Now, you're going to notice that it also says if you choose to complete a replacement exam. Otherwise, don't worry about this. So if you're a student who said, you know what, I'm not taking a replacement exam, this means nothing to you. Now, if you look in the final exam folder, obviously you say, look, click here for class. The second one down is where you're actually going to submit your final exam work. Here is the final exam formulas that you're going to be able to use. Okay, so you'll pop that up in a new one. You'll be able to see what that says. I feel a sneeze coming on. Maybe not. Okay, excuse me. The next one down is what we're going to be looking at today. There's a blank copy of the final exam review, and here's the copy that's keyed of the final exam review. And then the last thing on this page is the campus final exam schedule in case you were interested. So are there any problems or any issues looking at this page as far as the final exam stuff goes? Okay. So then what I want to do is, before we get started, is let you guys take a minute and let you guys either pop in with your voice or type something in the chat bar. Before we go forward, are there any questions, comments, or concerns from anybody that I need to address right now? Okay. So then what we'll do is we're going to spend today, so today's Monday, Tuesday, Wednesday, and even Thursday, really, if we feel that's necessary. And we're going to go over this final exam review. And when you go to take your final exam, it's going to be like the other exams that we've taken. It will be in Hawks. You will have to write it on paper and submit it to me. It's a 2-hour time limit. I sent out messages to each individual class to let you know when the final exam actually is going to be. How many questions are on the final? I want to say, hold on. I'm looking at my other computer screen. I think around 35. So it's not that much longer than just a normal exam. It just contains all of the information, potentially. All right, any other questions before we go ahead and get started on that? Okay. All right, so then if you want to follow along with me, just like always, you can. I'm going to go ahead and get my whiteboard up here. And basically what we'll do is I will start at the beginning of the review and we will just work through the questions. And as we work through the questions, we'll say, oh, you know, this came from chapter 1 or whatever the case might be. And we'll kind of bring back into your mind some things that maybe you've forgotten about or some topics, you know, like PIMDES, things like that. Factoring, just stuff that maybe we haven't done in a few weeks or whatever, that you're definitely going to have to know. So we're going to start at the beginning. And as we go through this, like I said, however you want to follow along, whatever, we'll work on this for maybe an hour. We're not going to do it all today because that's going to be a lot probably, but we'll see how far we get. And then, you know, just we'll take questions as they come. So here we go. So number 1 says to evaluate the following expression for the given variables. And so you're given a problem and it says the absolute value of x plus 9y. And then it says minus with a parenthesis 5z minus 6. And then it says 4x x equals -4, y equals +4, and z equals -4. And again, the instructions are to evaluate. And so when we see this type of a problem, what is it that we're going to have to do? How are we going to evaluate this?
Plug in your values for your letters and then just solve it.
Okay, and we're going to solve it using the order of operations. So let me jot that down over here. So here are the order of operations. And so we're going to take this x, this y, and this c, and we're going to pop them into their respective places. So that's going to give me the absolute value of -4 plus 9 times my y value, which is +4, minus the number 5, parenthesis, a -4 minus 6. And so I've plugged these things in. And so now what I have to do is I have to use the order of operations to solve this, or to evaluate this rather. And so what am I going to do first? Where am I going to look first? The P stands for parentheses. It also means absolute value, square root, anything like that. So I look inside. Look, here's some absolute value symbols. Here's some parentheses. So let's go in and let's do this. So looking in my absolute value signs, I'm going to do, first of all, 9 times 4. So I'm going to have -4 plus 36. And that's going to be in my absolute value symbols. Here's my subtraction sign. Here's my other parentheses. Well, inside these parentheses, I have 5 times -4, which is -20, and I'm still minusing 6. Well, guess what? I still have parentheses. So I have to go back and I have to say, okay, well, they're still not gone yet. So then I go inside these absolute value symbols and I say, okay, well, what is -4 plus 36? So it's going to leave me, it's going to leave me with the absolute value of 32. Here's my subtraction sign. Here's my parentheses over here. What is -20 minus 6?
-26.
And so now I'm almost there, really. I'm going to say, okay, well, what is the absolute value of 32?
32.
Just 32. What happens when I have minus a negative?
Plus a positive.
Plus, and then of course 26. So what is 32 plus 26?
58.
Okie dokie, done. So there's number 1. And so this particular type of question tests you in a lot of different things. The order of operations, absolute value symbols, what happens when you have minus a negative, can you multiply, all kinds of different things. So looking at number 1, are there any questions, any problems?
If the value in the absolute value sign was negative, then we would just take out the positive, right? So if it was like -32, it would just still be 32.
That is correct, because when we talked about absolute value, we learned that it's the distance from 0, and distance can never be negative. And so, yes, the absolute value must always be positive. Absolutely. All right, anything else on number 1? Okay, so then if you look at number 2, basically what this problem talks to us about are the rules of exponents. And so the problem is this. We have 5a to the -1 and then a b, and that is all over a b to the -1, and this entire thing is being cubed. And in the instructions, it says to simplify the following expression, writing your answers with only positive exponents. And so when we talk about exponents, we have to remember our MADs, okay? I think that this is probably just from Unit 1, honestly. This is the way that this review is listed out. It's not necessarily in any particular order, but I do believe that the exponents was from Unit 1. Okay, so when we talked about exponents, we talked about MADs, right? This is when we first learned about it. And we said if we multiply, we really add. If we divide, we really subtract. So the first thing that we have to do here is we have this power that the whole thing is being raised to. And generally speaking, when I have power to a power, what do I have to do with those little guys?
Add them together.
Not when I have power to a power.
Multiply.
Multiply. So this little 3 has got to hit the 5 and the A and the B and this B and this A. I have to raise each of these to the 3rd. So that's the first thing I have to do. So this is going to become 5 to the 3rd, and then I'm going to have a to the -1 to the 3rd, and then I'm going to have just regular old b to the 3rd, all over. And then down here in the bottom, I'm going to have a to the 3rd, and then down also in the bottom, I'm going to have b to the -1 to the 3rd. And so then I'm going to say, oh my gosh, but this is where we cannot get overwhelmed. When we have whole numbers and we have exponents and we have variables, we need to do our whole numbers first. So the only whole number I see is this guy right here. And so what is 5 to the 3rd? Well, that just means 5 times 5 times 5. So that's literally just the number 125. And this guy is taken care of. So, and then I said, all right, well, then let's do the letters in ABC order. And so let's take a look at the A values next, okay? And so if I look up here, I have this A, and it's power to a power. And so -1 times 3 is -3. And so on the top, I'm going to have A to the -3. And on the bottom, I'm not going to mess with anything yet. I'm just rewriting. I'm going to have A to the third. And so then I'm going to look at my B values, right? Because at least my parentheses are gone. And so I'll look at these B values and I say, okay, well, on the top for the time being, I have B to the third. There's nothing wrong with that. Then down here, I have -1 times 3. So that's going to give me B to the -3. Now, I know that it's tempting to say, hey, look, these negatives are going to cancel each other out.
Oh, you have to take it and put the negative on the bottom to make it pop, like switch the top or bottom it's on.
And we are going to do that, okay? But here's the thing, okay? Remember how over here we have MADS, and if we multiply, we add, and if we divide, we subtract? Technically speaking, when I look at these A values, I am actually dividing them. And so I need to subtract their exponents. So I need to do -3 minus 3, which is going to give me a -6. And so that overall, so hold on, so I'm getting ahead of myself. So 125 stays the same. And now I'm looking at my A values, and I have a top and a bottom already. And if my A values turns out to be A to the -6, where is that going to go, on top or bottom?
Bottom.
Yeah, so down here I'm going to have A. By putting it on the bottom, my 6 becomes positive. And so then I say, okay, well, let me look at my B values. I have 3 minus -3, right? This 3 minus this -3. Well, what happens when I have minus a negative?
Plus a positive.
And so that gives me B to the +6. And so B to the +6, that's totally fine. Where's that going to go?
The top.
Okay. And so then I say, all right, well, I don't have any more negative exponents. I only have one whole number, one B value, one A value. I can't simplify anything else. Nothing cancels. And so this is my final answer. So this was number 2. Okay, and now I'm done. And so with number 2, I'm testing you on the rules of exponents. Do you remember this MADS business? Okay, do you remember the top shelf, bottom shelf, the bookshelf thing? What are your thoughts? What are your questions? What are your issues, problems, whatever, with number 2?
So the A to the third, where it's circled in yellow because you're looking at the top A to the -3 and the bottom A to the 3, that A to the third on the bottom just stayed the same from the previous step.
Yeah. Because
Okay.
as somebody said, and I think it might have been Ashley, but I'm not sure, but somebody said, whenever we have this A to the -3, don't we have to bring it down here? Well, let's pretend that I did that. And we know that if we're multiplying, we really add our exponents. And so 3 plus 3 gives me this 6. So there's a couple different ways we could go about doing this. Honestly, I don't really care how you do it. You could do the subtraction, or you could just know, hey, I got to bring it down, whatever. What I care about is this where you end up? All right, any other questions, any other problems right now? Okay, so we'll move on to 3 then. Okay, so number 3, this is just a straight multiplication problem, and it says multiply the following polynomials as indicated. And so I have 5y squared plus x times y squared minus 3x. And so what I need you to do is I need you to multiply this. And when we have polynomials or sets of parentheses, what is the process that we use in order to multiply this?
FOIL.
Yep. Okay, and so now that's all we need to do. So let's FOIL this thing. And so here we go. And so if we have 5y squared and we multiply it by y squared, what's that give me?
5y to the 4th.
Yes. And then if I have 5y squared and I multiply it by 3x, what's that give me?
-15xy squared.
Perfect. And then if I come back into the inside here, x times y squared.
xy squared.
Yes. And then lastly, x times -3x.
-3x squared.
Excellent. Okay, so the multiplication is done. So I FOILed. Now, I always want to simplify. That's always my goal. And so in order for me to do that, once I get the FOILing done, I need to combine like terms. And so looking at this, are there any terms that I can combine because they are like terms?
The xy squared.
Yeah, these two pieces. And so my 5y to the 4th, whoops, that is a terribly drawn y. 5y to the 4th is going to stay the same. These two pieces right here, what's going to be combined? And so if I have -15xy squared and I add 1xy squared to that, what am I left with?
-14xy squared.
Perfect. And then my -3x squared is going to stay the same. And then this is it. I cannot combine any more like terms. I'm not trying to solve anything. I'm just multiplying and simplifying. So another part of the exam, as you guys have already seen in general, is making sure you're doing what the instructions ask. This just said multiply, bam, I did. Done. Questions, problems, anything? Okay. Wonderful. All right, so then let's move on to number 4. Now on this one, it says to factor the following trinomial. And you are given negative 5x squared y squared plus 25x squared y minus 20x squared. And it's asking us to factor. And so when we factor, we know that we're probably looking for something that looks like this. We're taking one thing and we're turning it into many different little things that are being multiplied together. And so when we factored, we had lots of different ways. We had the normal way, we had the AC method, we could have used the quadratic formula, we had grouping, we had common term, there was a bunch. And so we have to look at this thing. And the first thing that we have to decide is which method are we going to use here? Because that's the most important way. So
Probably AC, because you have a number in front of your.
Okay, so you're right in saying that I have this. However, when I use the AC method, I don't have two variables. So AC
use the
method,
common.
yes. So we're going to have to use the common term here. Okay, because since I have these 3 terms and there's the x's and y's, that's my go-to is using common terms. So I'm going to look at this. I'm going to say, okay, well, whole numbers first. I have -5, 25, and -20. What's the biggest whole number that each of these guys have in common?
-5.
A -5. And so then I'm going to say, okay, well, I have some x's and some x's and some x's. What is the biggest value of x that they have in common?
X squared.
X squared, okay. Excuse me, x squared. And then I see some y's and some y's and no y's. So -5x squared, that's all that they have in common. So I draw my parentheses and I say, okay, well, if I divide out what they have in common, if I have -5x squared y squared and I divide out the -5x squared, what does that leave me with?
Y squared.
Just y squared. And if I have 25 and I divide it by -5, that leaves me with the number -5. And my x squareds will cancel. And that'll leave me with just
-5y.
Perfect. And then I say, okay, if I have -20 and I divide it by -5, that leaves me with the number
+4.
+4, and my x squareds cancel, and that's it. So then I say, okay, well, I used the common term and I factored. Now I have to check to make sure I'm totally simplified. And I say, okay, this little guy out front, anything else I can do to simplify him?
No.
No. And then I look here and I say, this looks awfully suspicious. This is just 1y squared. And most of the time, if I have just a regular y squared, so the first step was common. The second step, if I just have 1y squared, what's typically my second step?
You can do the normal method.
Yeah. So this -5x squared is just staying exactly the same. Now I'm going to set up 2 empty sets of parentheses. I'm going to say, okay, I need 2 numbers that multiply together to give me 4 while adding to give me a -5. The variable they're giving me is a y, so I put a y in there. And what times what's going to give me 4?
-4, +1.
And -4 and -1, right? Because I need them to add up to give me a -5. And then I say, okay, well, we already said this little guy couldn't be factored anymore. Now this little piece, which is just y minus 4, can't factor that. This is just, okay, done. Now I'm telling you, wink, wink, on the test, when this was on our first test, a lot of you did not use the normal method. You just common factored and you said done, and you left me with this, and you weren't all the way right. And so what's going to happen is when you're doing this particular problem, we have to make sure that it is as factored as possible. Okay, so looking over number 4, excuse me, anything you need to ask me, tell me, say about this at all? Okay, then let's continue. All right, so number 5 is also a factor problem. And the problem looks like this. We have 6x squared minus 13x plus 6. And of course, the instructions are to factor completely. And so I look at this and I say, okay, well, I have this guy over here, and I think this was Bree that said this a minute ago. Since I have a whole number out front and it's x squared, which method am I going to use here?
AC.
AC. And so looking at AC, A is 6 and C is 6, so my AC number is 36. Okay, and so I need to think of numbers that multiply together to give me 36. Well, 1 and 36. 2 and 18. 3 and 12. 4 and 9, and that's it. No, it's not. 6 and 6. Whew. And that's it. Okay, and so now what has to happen is I have to pick one set of these numbers that are going to multiply together to give me this positive 36, but at the same time add up to give me this negative 13.
How about 9 and 4?
Yeah, that'll be perfect. And so if I need them to add up to give me negative 13, each of them are going to have to be what types of numbers?
Negative.
Exactly. And so what happens is this negative 13 is going away, and in its place, I'm putting both of these little guys. So I'm going to have 6x squared minus 4x minus 9x plus 6. And then we should all agree that if I were to take these two little guys right here and add them up, that gives me what I got rid of. Do we agree to that?
Yep.
Okay. And so then we are ready to now turn this into a grouping problem. And so I group the first two pieces, I group the second two pieces, and I say, okay, looking at these guys here, what do they have in common? What's the biggest number they have in common?
2x.
2x. And when I divide 6x squared divided by 2x, what's that leave me with?
3x.
And negative 4x divided by 2x is just
2.
2. And so then I look, and no matter what this sign is, add or subtract, it doesn't matter. It has to come straight down. And then I say, okay, well, I have 9 and 6. What's the biggest number 9 and 6 have in common?
3.
And negative 9x divided by negative 3 leaves me with
3x.
positive 3x. And 6 divided by negative 3 leaves me with a negative 2.
2.
And here's the important part. You have to say, okay, these two pieces, are they exactly the same? They must be, or we've messed up. So in this case, yes, they are. So I bring it out front, and I just write it once, and then I say, okay, well, what am I left with? I'm left with this little guy and this little guy. And so I say, all right, well, that's 2x minus 3. And right here is my final answer. Done. Now, again, in this problem, you have to realize it's not asking me to solve anything. It just says factor. And so I did, and now I'm done. All right, what are your thoughts? This was just a very straightforward AC method. Any questions, any problems? Okie dokie. Excuse me. Sorry, I'm drinking some lemon flavor.
So we don't have to set the 3x minus 2 and the 2x minus 3 equal to 0 and solve for x?
No. If that were the case, then instead of this saying factor, it would say solve at the top.
Okay.
Okay. So it's important for us to read our instructions. So it doesn't say solve, so I'm not going to say equals 0. I'm just factoring. Somewhere later on in the chart, somewhere later on in the study guide, you will see the word solve, and we'll solve, but not right now. Okay, so then let's continue with number 6. So number 6, here's the problem. We have the square root of, and then on the inside I have negative 8x to the 9th. And the instruction here is to evaluate the square root expression. And so a couple of things. Again, we're just evaluating. Okay, we're not trying to solve anything. But the first thing that should catch your eyeball is this is a negative number. And how is it that we learn to take the square root of a negative number? What did we have to do first?
Pull out the I.
Yes, we have to pull out that I. That's what makes it imaginary. So I'm going to first pull out the I, and then that's just going to give me a positive 8x to the 9th. Okay, and so we're going to pretend for just a sec that this I is not there. It will be, but we're just going to pretend like it's not. So I know you can't see me, but I'm putting my thumb over it. And all I can see is the 8x to the 9th. And so we're going to say, all right, well, if that were the case, if all we had was 8x to the 9th, when we did this, the first thing that we did was we separated the whole number from the variables. And so my I has to come with me, all right, just hanging out. And so this is going to become the square root of 8, and this is going to become the square root of x to the 9th. And then I say to myself, okay, self, is the number 8 a perfect square?
No.
No. What? Does a perfect square go into it?
Yep.
Yeah. So I is just making its way down. What's the biggest perfect square that goes into the number 8?
4.
And how many times does that happen?
Twice.
Okay. Now, when we look at this x to the 9th, remember there's a 2 out here. And we want this number 2 to be able to divide into this number evenly. And so how am I going to make the 9 into a number that the 2 can go into? I'll probably have a remainder. In fact, I absolutely will. But what am I going to turn that into?
10.
X to
Can't
the
build it up.
8th,
8, and then also,
X to the 1st.
yes, perfect. Because isn't x8, x1, if I multiply isn't that x9? Yeah, but if I somehow turn it into x10, it would be different. Okay, so now we're on our next line. So I is just I. What is the square root of 4? Just 2. What is the square root of 2? I don't know. How many times does this 2 go into this 8? Adam, no, you do not have to have this one power. It can just not be there at all, and you'll be totally fine. How many times does this 2 go into this 8?
4 times.
So this becomes just x to the 4th. And then do I know the square root of x? No, I do not. And so now I have taken the square root of everything that I possibly can. And so now I'm going to write it all out. And we learned that everything on the outside has to stay on the outside, and everything on the inside has to stay on the inside. So when I bring that idea together to write my final answer, I'm going to put my whole number first, so the number 2, then my variable, x to the 4th, and then of course my I, because he's just hanging out. And then these two pieces right here just go under one square root symbol, but they go side by side. And so now, here is my final answer. 2x to the 4th I times the square root of 2x. Done. So take a sec, look over this. What are your thoughts? This does a couple of things. It tests you on the imaginary numbers. It tests you on the power of I, so to speak. Do you remember what to do? Can you break apart variables? Can you break apart not perfect squares? What are your questions? What are your concerns? Anything at all?
Where did you get the red 2?
Okay, so we have said a couple of times, so this is just a side note, okay? Generally speaking, if we have something that looks like this, don't we verbally say the square root of x? Yes, we do. Okay, now what if I would have had a 3 right here? Wouldn't I say the cube root of x?
Yeah.
So it is an understood thing across the span of mathematics that when we say the square root, that there's a teeny tiny 2 right here. Okay, because we also learned that when we have the square root of x, it's actually x to the 1/2. Remember how we did that?
Yeah.
Okay, so it's the same thing with this. And so anytime you see a radical symbol that doesn't contain a 2 out front, we read that as the square root. And so in our mind, we have to know that there's actually an invisible 2 right here because we're squaring something, which means it times itself twice. Okay, does that help clear it up?
Yeah.
Okay, great. All right, anything else on number 6? Anything at all? Okay, so then let's continue on to the next one, number 7. So on number 7, the instructions say to solve the following linear equation. So this is the first problem that we've actually had to solve. So Sarah, this is exactly what I'm saying. We see the word solve, so we know we need x equals something, okay, or y or whatever. So the problem is 7 times 5y minus 3 equals negative 36 times 5 minus y. Okay, and so my goal is to get, in this case it's a y, to get y equals something because I have to solve it. And so here I go. And we can't overthink this. This is just a nice, neat linear equation, and I got to solve it. So what do I need to do first?
Distribute your 7.
Yeah. And I'm going to have to do it on both sides in this case. So here we go. So 7 times 5y, 35y. 7 times negative 3 minus 21. Equal sign. Probably need your calculator for this. I don't know.
Oof,
Negative
yeah.
36 times 5 is going to give me negative 180. 180. And then negative 36 times negative y is going to give me positive 36y. And so now this is done, so to speak. I don't need to look back. And so now I say, okay, well, on this line, I need to get my y values on one side and my non-y values on the other side. So what do you want to do first? Anybody?
Subtract 35, maybe.
Okay, sure. So we'll subtract 35y, and what I do to one side, got to do to both. And so that's going to leave me with negative 21 equals negative 180 plus y. Okay, now what?
Add 180.
Okay, so we'll add 180 to both sides. And so when I do that, that's going to leave me with y equals, in this case, 159. And now I'm done. Now, what are your thoughts on this one? Easy, right? Any questions? Any problems? What? So when you're taking this test, and you see a problem and you're like, whoa, that was too easy. Yes. Okay. Don't be like, oh God, that was too easy. I got to go back and I got to jack it up, because trust your gut. Okay. Believe me. All right. So what are your thoughts on this one? Any other questions or problems before we move on? All right. So number 8 is another problem. And you see again that the first word is, of course, solve. And so again, I need whatever variable, in this case, z, I need z equals something. Okay. This problem says 4z plus 4, and these are in the absolute value brackets, minus 19 equals 0. All right. And so now what we are trying to do here is we're trying to solve, and we are given absolute value brackets. And so before we can do anything on the inside, it has to be alone. So how am I going to get the absolute value brackets alone? What do I need to do first?
Add 19.
Add the 19. So I'm going to be left with 4z plus 4. Those are still in my brackets. If I add 19 to both sides, of course, this guy goes away, and I have equals 19. Now, let's pause for a sec. When we talk about absolute value, we said that the absolute value is distance from 0. So if, okay, again, you have to pretend like this is my thumb, okay, my big old green thumb, because I've been growing plants lately. Here's my big green thumb, okay, you can't see that, all right? My question is, if this is my thumb, what's the number that I can put? There are 2 numbers that I can put on my thumb that its absolute value is 19. One of them is over here, and one of them is over here. What's the one to the far right? What's this number going to be?
19.
Positive 19. What's the number on the far left going to be?
Negative 19.
Exactly. So what has to happen is I have to say that whatever the stuff is under my thumb, whatever it is, I don't care. It has to equal negative 19 or it has to equal positive 19. Those are my only options. So I'm literally going to write 4z plus 4 equals negative 19, or 4z plus 4 equals positive 19. And now I got to focus on just these 2 equations, and that's it. The rest of the stuff I don't care about. And so over here on the left, I have 4z plus 4 equals negative 19. Well, I'm going to have to minus 4 from both sides. That's going to give me 4z equals, negative 20. Oops, I've already messed up. Negative 23? I hope so. Okay. And then, of course, in order for me to solve this, I have to divide. And so I'm going to get that z equals negative 23/4. Okay, that's the first one. Or, and then I'm going to come over here, I'm going to minus 4 from both sides. I'm going to get 4z equals 15. And then I'm going to divide by 4, and I'm going to get z equals 15 over 4. And so collectively, I should have waited to circle that, but I have 2 answers. And it's going to be z equals negative 23/4 or z equals 15/4, and now I'm done. So this particular question is really just saying, hey, do you know about absolute value? And when we took the test last time, some of the issues that I saw is a lot of us forgot to do this one, right? We just did the positive 19, and so you only had 1 answer. And so because of that, you only got half credit because technically you're only half right. So any issues, any whatevers, any problems with number 8 right now?
Mm-hmm.
Okay. Guys, you got to stop me, okay? Because otherwise, I'm just going to keep on keeping on. So I'm checking the chat box and making sure. No, okay. All right. So then let's take a look at number 9. Now, this is the one that we kind of liked. Some of us liked it because it was more applicable to real life. It's the tip question. Okay. So Marvin decides to leave a 15% tip after eating dinner. If his bill was $27.32, how much should he pay? And when we tested on this, we had said, I stuck the word total at the end. How much should he pay total? So we already know that his bill is $27.32, and we know that he wants to leave a 15% tip. These are the pieces of information that we're given. Well, how do I figure that out? What do I do? Anybody remember?
You take 15% times your
Times what you
amount.
Exactly. Now, can I type this percentage button into my calculator?
Some of us can.
No, let's say no.
Okay.
So, no, because not everyone has that percent button. I hate that percent button, but not everyone has that ability, okay? So we know that when we see this percent sign, we have to take our decimal point, we have to scooch it over 2 places to the left. So technically it's right here. So we're going to go boop, boop. And so it's going to be 0.15. And so we're going to take the 0.15, and I'm just writing this out as a big problem, but of course you're going to type it in. So we're going to take $27.32 and we're going to multiply it by 15%. And when I do that, I'm going to round it off to the nearest cent and I'm going to get $4.10. Now I got to be careful because I'm getting a lot of stuff everywhere. So we know that this money is actually just the tip amount. Okay, now the question is, how much should he pay total? So we're going to take the total he already owes, and we're going to take the amount of tip he's going to leave, and what are we going to do with these two numbers?
Add them together.
Yeah, so we'll have $27.32, and we're going to add $4.10. And again, you'll type this in, and when you do that, you'll get $31 and
52 cents.
I got 42.
Yeah, I
I
got
did
42.
42 instead of 32.
It's okay. Okay, and so now that's it. And so in Hawks, in your paper, you'll circle this. You'll just type in 3142. Bam, done. Okay, so what do you think about the tip question? Any issues? Any problems with that?
Pretty straightforward.
Yeah, I mean, yeah. Okay, so then we will continue. And number 10 is where we are now. And this one is an inequality. And there are let's see, 1, 2. There are a couple of things you have to do here, okay? Well, first of all, I guess it would help if I wrote it down. Negative 34, inequality symbol, 3y minus 7, inequality symbol 2. Okay, and so step 1 is to solve. And step 2 is to put on a number line. Okay, and so again, when we have solve, our goal is to get y by itself. Now in this question, we're not going to get y equals because it's not an equation. So our goal is to get this y that's in the middle totally alone in the middle. And so we have 1, 2, 3 sides. And so in order for me to get this y by itself, what's the first thing I'm going to have to do here?
Add 7 to all sides.
Exactly. So I will add 7 to all sides. And when I do that, I'm going to get negative 27. I'll be left with 3y in the middle and 9. And then I say, okay, well, here's that y value that I still need right here. And so what am I going to have to do to get it all by itself?
Divide 3.
Mm-hmm. And so when I do that, I'm going to get negative 9, inequality symbol y, inequality symbol 3. And so I went ahead and guess what? I solved it. Here's y by itself. So here's the answer to the first part. Solved it. Done. So then it also says to express this in interval notation. And so right here are my intervals. And based on these inequality symbols, that will tell me if I'm going to use a parenthesis or a bracket. And so how far left is this thing going? Well, to negative 9. And based on this inequality symbol, parenthesis or bracket right here.
Parentheses.
Okay, good. Comma. How far right does it go? Well, the number 3. Based on this inequality symbol, parenthesis or bracket. Okay. And so then it says solve, check. Interval notation, check. Now it says put on number line. Well, I'm going to take this guy right here, and I'm going to slap it onto this number line. So here's negative 9, and here's 3. Well, at negative 9, I'm putting a parenthesis. It's heading towards the right. At positive 3, I'm putting a bracket. It's heading towards the left. Hey, look. Done. Okay, so
Can you use like a closed circle and open circle?
absolutely. So this would be your open circle. Here would be your line. Here would be your closed circle. That's totally fine. Whichever you prefer. I don't care.
Now, if the 3 would have been a negative 3 to divide with, that's when we would have flipped the signs, right?
That is correct.
Okay.
All right. So any issues? Any other problems on number 10? Okay. So then we will continue. Okay, so if you look at number 11, here's the problem. We have 64y squared minus 400 equals 0. And the instructions say to solve by factoring. Okay, solve by factoring. So those are my instructions. Okay, and so I look over here at my problem and I say, oh my gosh, which factoring method should I choose here? Now there's one factoring method that even though we talked about a few, we didn't actually say this one out loud. And we're going to pause for 1 sec because I want to make it a little more straightforward. What if I had this x squared minus, I don't know, let's say 36 equals 0.
Oh, you just have x plus 6 and x minus 6.
Yeah, and what was that called? Does anybody remember?
Square root method?
Difference of squares?
Difference of
Yeah,
squares.
difference of squares.
Okay, so
Throwback.
what is it?
I said throwback.
Throwback, yeah. Throwback Monday, I guess. Doesn't quite rhyme. But Anyway, we got to remember, okay? So let me get rid of this easier one and let's look at this rougher one, so to speak. And so what happens is if we remember difference of squares, we have, or it says if we have a squared minus b squared, that is equal to a minus b and a plus b. And so in the past, when we did these types of questions, we looked at these little guys right here and we said, okay, well, this is going to be my a, this is going to be my b. And we said, all right, what number squared gives me 64?
8.
8. And what value of y squared gives, or no, excuse me, let me back up. What value of y, when I square it, gives me y squared?
Y.
Just y. And so now, over here, let me write on this in yellow. This is my a squared. Okay, let me see if I can do this better. I should have put the, yeah, okay. So my a is just 8y. Check. Subtraction sign. Now I need b. And so I look, so let me write b. So I look in my, I look at my letter, or I look at my number rather, and the number is 400. And I say to myself, okay, what number when I square it gives me 400? 20. And so now I have this value as my a and this value as my b. Check, check. And so now I'm going to very easily be able to write this out. So I'm going to have 8y minus 20 times 8y plus 20, and that's going to be equal to 0. And since the instructions over here say solve, I actually have to get y equals something. So let me pause for 1 sec, okay, because the rest of this is going to be pretty straightforward. Are there any issues with the beginning till right now? So I looked over here, I said, oh, this is difference of squares. I found my a, I found my b. I said, hey, guess what? A squared, or a minus b, a plus b. And so then I'm going to say, well, since I have to solve, I'm going to have 8y minus 20 equals 0, or I'm going to have 8y plus 20 equals 0. And then I'm going to add 20. I'm going to get 8y equals 20. And then I'll divide by 8. Then I'll simplify. Let's see, I'll get 5 halves. Over here, I'll minus 20. I'll get 8y equals negative 20. I'll divide by 8, and I will get negative 5 halves. And these two together will be my answers, positive 5 halves or negative 5 halves. So take a sec, look at that. What do you think? So this particular question, of course, is testing you on factoring, but it's testing you on the difference of squares, a special type of factoring. Oh, excuse me. So any major issues with that? Okay. So we have a few more factoring problems here in a row. So let's get on to those. So then, fine. Number 12 is another factoring question. However, it says to use the square root method. Square root method. And so the problem is negative 5 times y plus 6, the whole thing squared, equals negative 45. And so since we're using the square root method, if we think way, way back, generally speaking, when we use the square root method, somewhere along the line, we got to take the square root, okay? Let me see how many problems are on the review. Heather, I believe that there are 35 problems on the review, just as there are on the final. So maybe we do half today, half tomorrow. I don't know. It's going to be up to you guys, okay? Okay, so here we go. So we know that this is the piece right here that's being squared. That 5 is not being squared. So how am I going to get rid of this 5?
Divide it.
Yes. So I'm going to divide both sides by negative 5. So of course that will go away. That will leave me with y plus 6 quantity squared. Negative 45 divided by negative 5, positive 9. Now the thing that's being squared is now alone. So I can take the square root. But of course what I do to one side, I got to do to both. So on the left-hand side, the square itself and the root will cancel, which leaves me with y plus 6. Now, here's the thing. What is the square root of 9?
3.
And also?
Negative 3.
Yeah, so this is where we can't forget our plus or minus. Now, when we get to this step, a couple of us, we do it different ways, and I don't really care which way you do it. Okay, you can minus 6 first, and you can get that y equals negative 6 plus or minus 3. Or you can go ahead and say that y plus 6 equals positive 3 or y plus 6 equals negative 3. I don't care how you do it. What I care is that you have 2 answers. And so regardless of how we do this, the first one we're going to get is y is equal to a negative 3 from this guy or this guy, whichever, with the plus. And the other one is going to be y equals -9. I don't care how you get these two numbers, which method, so to speak, but I need to know, do you have any problems or issues on getting them? Because that's my main concern. So if you do this method, if you do the one over here, that's pretty easy, but let me finish this one real quick. So that gives me -6 plus 3, or it gives me -6 minus 3. It's exactly the same thing as this. It's just written out differently. Okay, either way, I'm going to get the same exact answer. So number 12, square root method. Any issues, any problems?
Mm-mm.
Okay. All right, so then let's go ahead and do number 13 because it's another factoring problem. So if you look at 13, it's the same type of a question, so to speak. Again, it's saying to solve. However, it is very specifically saying use the quadratic formula. Okay, so here it is. X equals the opposite of b plus or minus the square root of 4ac all over 2a. So there's your quadratic formula. Hold on. No, it's not. My gosh, Amanda. B squared
minus 4ac.
I'm like, wait, that doesn't look right. Why is that too short? Sorry, guys. Okay, so here it is. Okay, and so here's the problem that they give us. We have y squared plus 4y minus 6 equals 0. And so the first thing Amanda would do is say, hey, a is 1, b is 4, and c is a -6. And then I take these three little guys and I pop them into this formula. And so what I'm going to have is I'm going to have -4 plus or minus the square root of 4 squared minus 4 times 1 times -6 all over 2 times 1. Okay, so what are your thoughts on just this? Any issues, any questions, anything at all? Okay, so then I'm going to get rid of these pieces and I'm going to go ahead and start working this out. And again, I know it's very tempting to just grab that calculator, start banging away on it. Okay, but maybe not. All right, so we're going to be left with the opposite of 4 plus or minus. Well, 4 squared, that's easy, just 16. Subtraction sign has to come next. Now, maybe in your calculator, you do this. +4 times +1 times -6. And when I do that, so 4 times 1 is just 4. And 4 times -6 is -24. So I have to put a -24. But now here's what's happening. Pay attention, because I have minus a negative. What happens when I have minus a negative? What does that turn into?
Plus a positive.
Okay, so this becomes plus. And then down here, I just have 2 times 1, which is just 2. So I'm going to keep going. So -4 plus or minus inside 16 plus 24 is going to give me the number 40. And that's all going to be over 2. Okay, what are your thoughts so far? Everyone okay?
Mm-hmm.
All right. And so, of course, our goal is to always simplify as much as we can. And so we look at this little guy, we say, is the number 40 a perfect square? Well, it's not a perfect square. However, what's the biggest perfect square that's going to go into 40? How about just the number, how about 4?
Yeah.
Over here, -4 stays the same. Here's my plus or minus sign. This square root of 40 is going to turn out to be the square root of 4 times the square root of 10. It's all still over 2. Okay, well, guess what? This -4 is not going to change. This 2 is not going to change. Do I know the square root of 4?
Yep.
Just 2. Do I know the square root of 10? No.
No.
So this turns into -4 plus or minus the square root of 2, or no, plus or minus 2 square root of 10 over 2. Oh my gosh. Okay, I'm so close to being done. The last thing I have to do is say, hey, look, this is a leading, or this is a whole number, this is a whole number, and this is a whole number. Do these whole numbers have anything in common? And this is the place where it has to be all or nothing. Do they all have something in common? Someone said it.
2.
2. And so -4 divided by 2, 2 divided by 2, and 2 divided by 2. Well, that's going to leave me with a -2. This is going to cancel. So plus or minus square root of 10 is still there. This, of course, is just 1, which I don't really need in the bottom. And so after all of that, this little teeny tiny guy right here is my complete and total final answer. And I would ask, oh, go ahead.
So like you said, all or nothing. So like if that 2 in the bottom wasn't there, you couldn't divide.
Okay. If this 2 in the bottom, let me get a different color here. Let me do it in, let's say, bright orange, or bright green rather, so you can see it. If this 2 would have been a 3, let's say, the number 4, the number 2, and the number 3, they all don't have something in common. So I couldn't divide. Now, if that 2 would have just not been there at all and there was nothing down here, then the only 2 numbers that I would have was this guy and this guy. And they still have something in common, so I could still divide. Do you see what I'm saying?
Yeah.
Okay, so I'm gonna put my 3 back down. Or no, excuse me, my gosh, it wasn't 3, it was a 2. All right, so start to finish, what are your thoughts on the quadratic formula?
It's not bad.
Now, since we're taking this exam in Hawks and it's been a while since we've done this section, just to be honest with you, I can't remember if they're going to make you type in 2 answers or if they're going to let you type in just 1. We have to know that this is my final answer, but we also have to know, what does this mean? Just in case there are 2 things that this means. What are those things? What are the
Negative
answers?
2 plus square root of 10 and negative
Yeah.
2 minus square root of 10.
Perfect. Okay, so if Hawks will let you, just type in 1. You're fine. But if it says, hey, give me 2 answers, just pull it apart and tell me what it means. But again, remember, I grade these by hand, so just write everything on your paper. And if you mess up something by typing it in wrong, whatever, I look at your paper and I say, oh, you got it right. Okay, so don't fret over that. You guys have seen the notes I've put on your exam when I've given them back to you, as far as maybe you typed something in wrong or whatever. Okay, so 13. Any other questions or problems on quadratic formula?
Mhm.
Okie dokie. All right, so then if you take a look at 14, number 14 is one of those rational expressions. Okay, so 14 is big. So let me write it down. Let me write it down here. I have z squared plus 6z minus 7 over z plus 5. This is being divided by z squared plus 5z minus 6 over z plus 9. Now, it's important to pay attention to what the instructions say. Here, the instruction says to divide. Okay, I'm not trying to solve. I'm just trying to divide. And then, of course, it goes on to say, and simplify if possible. Well, that's definitely our goal. So now I want you to just think about this for 1 second. If all I had were fractions, teeny tiny fractions, I know I'm making this up totally. What would I do in order to divide fractions? How do I do this? What is it that what's my
Flip it.
Multiply.
yeah, flip it and multiply. So what do you think I'm going to do to this big one? It's still a fraction.
Flip and multiply, but
Yeah.
you got to factor the top.
Exactly. Not just the top, but okay, I see what you're saying. I have to factor both of these guys. So let's do 2 and 1. Let's flip it and let's factor at the same time. So over here on this top, can I factor it? So maybe I need 2 numbers that are going to multiply together to give me a -7 while adding to give me a 6. Is that going to happen?
Yes.
Yeah. What are those 2 numbers?
7 and 1.
How about 7 and -1? Okay, so the top is factored. Now the bottom, z plus 5, well, that's not going to factor, so I leave it alone. Now I'm going to flip this thing upside down and also multiply. So here's my multiplication dot. This z plus 9 is now on the top. I'm going to say, okay, this guy over here, can I factor him? Well, are there 2 numbers that are going to multiply together to give me a -6 while adding to give me a +5? How
3
about,
and 2.
well, maybe, but the only way for me to get a -6 when I multiply is to have a -3 times a +2 or a -2 times a +3. And if that's the case, they're not going to add to give me this 5. So what are some other factors of 6?
2 and 3.
No, right? Because we just did that one.
Oh. 1 and
How about
6.
1 and 6. There you go. Okay, so if we need them to add to give me a +5, that means my 6 is going to have to be negative. Now, when we did this section, the coolest part about this was technically we're supposed to be multiplying, but if we could factor first, then there was a good chance that we could get rid of some things. We never really actually multiplied. So we have 1, 2, 3 pieces on top, and we have 1, 2, 3 pieces on bottom. And I say, okay, are any of the pieces on top exactly the same as any of the pieces on the bottom?
Z minus 1.
Z minus 1.
Okay, -1. And sometimes there's more and sometimes there's not. In this case, there's not. And so once we got rid of everything that we could, we literally just take the tops and set them side by side. And then we take the bottoms and we set them side by side, and that's it. And so this is going to be z plus 7 sitting beside z plus 9 over z plus 5 sitting beside z plus 6. We do not refactor, we do not refoil, we do not anything. This is my final answer. It's big, it's ugly, I don't care. I took 2 big, nasty looking things and I made it significantly smaller. And now I'm done. That's it. So take a sec, look over 14. Let me know what your questions are.
So we only flip the second part of it?
That
For
is
some
correct.
reason, I remember flipping both.
No. Okay, we never flip both because the rules of fractions are when you divide fractions, you flip and multiply, but you only do it to the second one.
Okay.
Okay. All right. Anything else right now on 14?
Is there going to be one on the final exam where when we factor the top or the bottom or whichever one, it's going to be the AC method?
To be honest with you, I don't know because I haven't got that far. Okay. I hope not because that's a lot more work than is needed. But again, I don't have the final major. I'm working on that later today. Okay. Any other issues on 14? Okay, so then let's take a look at 15 and we'll see what this looks like. So number 15, the first word I see is the word solve. So before I do anything, I know I need variable equals something. So x equals something. So here's the problem. The fourth root of 5y minus 6, and that whole thing equals 3. And so my goal, because it says solve, is to get y equals something. And so the y value that I need, of course, is right here, stuck under the fourth root. Well, what's the opposite of me fourth rooting something? How am I going to get rid of this fourth root right here?
Raising it to the fourth power.
Exactly. So I'm going to raise this side to the fourth power, but what I do to one side, I have to do to both. So on the left-hand side, the fourth root and the fourth power will cancel. And what that leaves me with is just 5y minus 6. Perfect. And then over here, 3 to the fourth means 3 times 3 times 3 times 3. So we plug that into our calculator, and that'll just give me 81. And so now I have a nice, neat linear equation, no big deal. Any questions to this point?
I like it when it just cancels out.
Me too, right? This is gonna be a quick one for you. Okay, and so then of course here's the y, and I got to get it by itself. So what do you want to do?
Add 6.
Yep. So I have 5y equals 87. Okay, now what do you want to do?
Divide 5.
And so I'm going to get y equals 87 over 5. It just so happens this guy doesn't simplify. Bam, done. So when you look at this problem, no matter, whoops, that was a 4, I erased it. No matter what number this is, okay, so whatever this number is, 5, 6, 10, 1, 2, 3, whatever, just raise it to that power to get rid of it. Any problems with 15?
Nope. Pretty easy.
Yeah, that was a pretty easy one, huh? Okay, I had to step away for a moment. The dog's got his harness on and he got scared. Okay, all right, so number 16. This is one of those word problems that everyone's afraid of until you read it and ask what it's trying to figure out. So number 16, you're in London, okay, and you're looking at your map, right? We talked about maps, and the grid that you're looking at represents 0.25 kilometers, okay? And there's a tower, I don't know how to say that, so there's some London Times Square or whatever is located at -2, -3 on your graph. And the castle is located at 2, -5, okay? And so what we're trying to figure out is the total distance. We don't mean, the walking distance. We mean straight line as the crow would fly. I need to know what is the real life distance between those two landmarks. And I need you to give that to me in kilometers. Well, so here's what we know. We know that one of our locations are at -2, -3, and the other one is at 2, -5. And in the problem, it literally says find the distance. And so how do we find the distance?
Using the distance formula.
Exactly. So step 1 is find the distance. The second thing, once we find the distance, remember, when you look at a map is not the true actual distance. You have to blow it up, so to speak. You got to make it bigger. So once we find the distance, step number 2 is to multiply by 0.25, right?
Mm-hmm.
Okay, so there's the plan. And so if we think of the distance formula, if we think way back, it's going to be, let's see, the distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 whole thing squared. And so what would Amanda do? Well, Amanda would say, hey, look, this is x1, y1, and this is x2, y2. And then you take the points that you're given, you plug them into the distance formula, and you solve it down. And so when I do that, what I'll have is x2 is the number 2, minus x1 is a negative 2. That whole thing will be squared, plus sign. My y2 is a negative 5, subtraction sign. My y1 is a negative 3. That whole thing is squared. And the whole entire thing is still under the square root symbol. And so then I say, okay, well, underneath, or inside rather, what happens when I have minus a negative? That turns into
Positive.
plus a positive. So this becomes 4. And then over here, what happens when I have minus a negative?
Plus positive.
So this becomes what, negative 2?
Yep.
And the whole thing's okay. And so then I'm still inside here. And so what is 4 squared?
16.
And what is negative 2 squared? Now, pause. All right. I'm telling you right now, if you have your fingers on your calculator, parenthesis, negative 2, parenthesis squared.
Because it's going to give you positive 4.
Positive 4, yeah. And so when I add it up, I'm going to get the square root of 20. Now, usually I say, guys, I need you to take the square root and I need you to break it down, okay? But in this instance, I don't, because you have to multiply it anyway. So you're going to take the square root of 20, whatever it is, I don't know, okay? And you're going to do, this is just a multiplication dot, it's not times, and then you're going to put 0.25, and you're going to type that into your calculator, and you're going to round it off to the nearest, 2 decimal points, whatever. And so when we do that, we're going to get 1.12 km for kilometers. Make sure that you are typing this in and you're getting this number. Do it right now. Now, when you're doing it, make sure that when you type in your square root, you use your arrow button to come out. Then hit your multiplication dot. Otherwise, the calculator is going to assume that you're trying to take the square root of the whole thing, and that is not what we're trying to do. So take a sec, see what you got. Let me know if you have questions. Anybody have any issues with this one? Now, the thing that I think that most of us had forgotten last time when we did this on the exam was step 2. You have to multiply to blow that back up. Because remember, think about a map in your hand. That's not the true distance, right? You know that when you're walking around a new city. You have to make sure that you take that into consideration. All right, so let's move on to 17 then. Guys, hold on one second. Okay, so 17. 17. This says to solve, but then it gives me 2 linear inequalities, and it says do it graphically. Okay, so they give me the inequality 4x plus 4y is less than 24, and x is greater than or equal to 2. And basically what's going to happen is I'm going to have to draw a picture. Okay, because it definitely tells me to do it graphically, and it gives me an actual graph on which to put it. So when you're doing this problem in Hawks, you're going to want to draw this out, and then you'll color it in on Hawks as well. Okay, so here we go. Actually, I don't want that symbol. I want the word in, because that's going to be important. All right, so when we talk about lines, when we talk about inequalities, we know that when we have inequalities, we don't just say y equals 2 or 3 and we call it done. Okay, we have to actually find a section of the number line that my inequality, yeah, that's what we're gonna do. Okay, we're gonna do half today, half tomorrow. So we'll do up to 18 today, because that's pretty much halfway through, and then we'll do the rest on tomorrow. And then Wednesday will be questions. Wednesday and Thursday we'll use for extra help questions. How's that? Does that sound like a fair deal?
Mm-hmm.
Yeah.
Okay, so let's do this one and then one more, and then we'll be done for the day. Okay, so here we go. So the first thing that we have to do is we have to try to get each of these into slope-intercept form if possible. So I'm gonna do this one in red. So in other words, I need y by itself. How am I gonna do that?
Could you substitute
Divide
0
everything by
and
4.
I could, but I want to get the y. I don't want to divide first. Okay, I don't want to do the division first. So I'm gonna have 4y is less than negative 4x plus 24. Now I want to divide everything by 4. And the reason why is, Sarah, is because sometimes your slope is a fraction, and I don't want fractions. I don't want to have to add or subtract fractions. So when I do my division, I'm going to get y is less than negative 1x plus 6.
Mhm.
And really, I don't need that 1. And in fact, I don't really want to put it there. Now, from this little guy right here, I know several things. I know the slope. I know the y-intercept. I know if the line that I'm about to draw is going to be dashed or solid. And I know if I'm going to shade above or below it. So just looking at this red one, what is the slope?
-1.
-1/1.
Uh-huh. And what is the y-intercept as a point? 0,
6.
6. Perfect. Okay. Now, based on this inequality symbol, it says y is less than. So am I going to shade above or below this line?
Below.
Below.
Okay. And since it says, or since it's a single inequality symbol, so to speak, am I going to make a dashed or a solid line?
Dash.
Dashed.
Okay, so I want to do that first before I do anything else. Okay, so I have to add a few little dots here, but that's okay. All right, so in red, I'm going to plot my intercept, my y-intercept 0, 6. So start at the origin, go up 6, 2, 3, 4, 5, 6. So right here. And then my slope is -1/1, which means down 1, right 1, down 1, right 1, down 1, right 1. So down 1, right 1, down 1, right 1. And again, of course, you're going to have graph paper, so it's, or on Hawks, it's going to look much better. Okay, so it's going to look something like that, okay? We already said it was going to be a dashed line, so I can draw my dashed line through there. And we said we're going to shade below. So if this is A and this is B, where's below?
Okay.
Okay, just making sure. And so then I will take the whatever color I have, whoops, no, and I will shade below. Okay, cool. So there it is. All right, now, I'll do in blue, I suppose. This x is greater than or equal to -2. So we learned way back that if we have x in a number, what kind of line is that, generally speaking?
A solid.
Okay, it will be solid, but that's based on the inequality symbol.
It'll be vertical.
Vertical, yeah. And where is this going to be? If x is greater than or equal to 2, well, what's the line? X is equal to the number 2.
2.
And so I start at the origin and I go right to, and I put a dot. And you already said it's vertical, so that means it's going up and down. You already said it's solid. So here's my vertical solid line. Okay, something like this. Now, this says x is greater than or equal to 2. Now, if this is A and this is B, am I shading A or B based on the fact that it's greater than?
B.
Yeah, because I'm saying, okay, if I chose a number, so let's say we pick 10, which is over here somewhere, is 10 greater than 2? Sure. So I'm going to be shading to the right of this thing. So let me get my pen back out. Let's do that. So here we go. All right, I'm shading this way. Okay, so it looks something like that. Now, here's the important part. The instruction says to solve. So I'm trying to find the solution set. I'm trying to find the area of the graph that makes this inequality and this inequality true at the same time. And so since I see the word and, does anybody remember what the word and means?
Where they intersect.
Intersection, yes. And so intersection. So looking at this, if this is A and this is B and this is C and this teeny tiny spot is D, where's their intersection? Where do they overlap each other?
B.
Yeah. And so you'll get your pencil or your highlighter or whatever it is that you have, and you will shade this area and you will say, okay, this is their intersection. And now I'm totally and completely done. What are your thoughts on 17, start to finish? Questions, problems, anything at all? All right, I think actually when I look at 18, that's a circle question. Let's save that for tomorrow. So we've done 1 through 17, okay? And so now you have half of the final exam review done. What are your thoughts? What are your questions? Is there anything that we want to go back and take a look at, or that you want to ask me, or that you want to type in that box? As far as the rest of this week goes, anything at all, now is a good time to do so.
That last problem we just had, if it said or, it'd be union, right? And
That is
then we
correct. And
highlight
so if-
everything but what we just did.
Mhm.
Okay.
Yep, that's it. That will be the difference. Okay, anything else for right now? Okay, so I don't know if you guys have had a chance to look over your Unit 5 exams, but like I said, I stuck notes in there and I said, hey, we didn't do work like this or whatever. So I need to make sure that you are not just photo apping or math apping or whatever it's called, where you just take a picture, you submit it, and they pop out some work. I'm not calling people out names. I'm just saying, guys, overall it happened and we can't let that happen. So again, if that was you, just please try not to do that again. Okay, please don't do it again because I know, and it's disappointing. So I'm going to work here at my computer for a while, and I'm going to send out messages to you guys and say, hey, you know, Billy, I think you should take replacement exam number 4. What are your thoughts? And then Billy will respond, and then we'll have a plan. And that's that. So anything else? Otherwise, I'll just get to work, and you guys know what's out there for you. I'm going to put some practice stuff in Hawks today as far as the final goes and give you as much information as I possibly can. So if you want to hang back and ask me questions, you're more than welcome to do so. Otherwise, I'm done, and we'll meet back tomorrow at 2, and we'll pick up from there. So if you're good, I'm good. I'll hang back for a minute. Otherwise, I'll see you guys tomorrow. You're welcome. Anything else?
Thank you. Have a good day.
Hey, thanks. You too.
Amanda, can I ask you one more question?
Absolutely. Go right ahead.
On number 16 with the kilometers, if
Uh-huh.
it's like any other, like, it's kilometers, but like if it was miles, would we still multiply it by whatever it was?
Yeah. It doesn't matter what the units are. It could say feet, inches, miles, yards. It doesn't matter. You're just going to multiply by whatever the unit scale they give you is.
Okay. Thank you.
You're welcome. Anything else, guys? I still see a few of us hanging in. Anything else? Okay. You guys have a great day, and I'll see you guys tomorrow, okay? In the meantime, shoot me a message if you need anything. All right. Bye, guys.